the last video, I showed you my very DIY boost converter prototype. I am building a device that is powered from 3-volt battery, and I want to use a motor that requires 5 volts. Of course, I could just buy a ready-made boost converter module, but where's the fun in that? With the use of inductor and PWM-driven transistor, we can boost the voltage. There are several parameters that we can adjust: PWM frequency, inductor size, PWM duty cycle ranges, and instead of a simple step-by-step adjustment, we can implement something like PID controller. Before I used it with motor, which is a changing load, I wanted to make it simple, so I used the resistors, starting from 500 ohms, about control algorithm. We will try to increase the PWM frequency until we get the desired output voltage, which we check via ADC. For the first test, I implemented a very simple control loop. Start PWM, then in the loop read the ADC, check if the voltage is below the desired value, and if the PWM duty cycle is below the allowed maximum. If both are true, increase the duty cycle slightly, which should result in increasing the ADC value. Otherwise, if duty cycle is above the minimum, decrease it. Nothing fancy, just a quick way to regulate the voltage. The goal was to put it quickly together, so I used Arduino and my Xiao board. Here you can see the algorithm as I just explained. But guess what? The PWM frequency is fixed to 500 Hz. It's enough to verify the algorithm though. However, there's another library using Embed where you can actually specify the PWM frequency. So I connected the test voltage directly to the ADC and looked at the PWM output on the oscilloscope while changing the input voltage. The duty cycle changed exactly as expected, so the control loop worked. Encouraged by that, I connected the full boost converter chain. With 500 Hz PWM, I reached only less than 3 volts at the output. Not great. So I switched to the Embed PWM implementation and increased the frequency to 1 kHz. And it turned out not all the ground paths were actually connected. After I fixed that, I managed to get 5 volts. I slowly decreased the resistance, increasing the load, and whenever the converter started struggling, I increased the PWM frequency. Eventually, I managed to reach about 200 mA using resistive loads. And the next step will be the real challenge, connecting the motor, which is a much more dynamic load. So I modified my setup to add this kind of a switch to simulate the motor. Not perfect, I know, but should be good enough. Let's switch the resistance and see whether the voltage recovers quickly. Not too bad. Time to connect the motor. Will this end up in a final device? Probably not. You can buy a module for as much as €1.5. But I think it's a great way to understand what's happening inside.